Today's topic is inclined plane projectile. You must have done the projectile on ground and there are some specific formulas for that. But in inclined plane projectile, those formulas will not work. So today I will discuss how we will treat this type of problems. I am DATTA sir. I am a IIT faculty for many years and an ex-physics professor of a number 1 IIT Institute of India. I am making video of various small concepts of physics for the benefit of the students. If you are one of them, definitely it will be helpful for you. And if so, please like this video and share this video. And also subscribe to my channel because I will be posting this type of video regularly. And if you want further video, you can send me your comments so that I can decide on that. So now let us go to the topic. So today's topic is inclined plane projectile. Now let us say there is an inclined plane OA inclined at an angle alpha with the ground. Now from O a projectile is thrown with an initial velocity u at an angle theta with that inclined plane and it falls on A. So if we have to find out the time of flight and also the range, then what we will do? We will at first fix up a set of axes OX and OY. OX will be along OA and OY will be perpendicular to that. Then U will break along this x-axis and y-axis. So x component of U will be U cos theta, y component of U will be U sin theta. And since G is vertically downwards, we have to resolve G also, one along the plane and another perpendicular to the plane. So the component of G along the plane will be G sin theta and that perpendicular to the plane will be G sin alpha and the component that is perpendicular to the plane will be G cos alpha. So now we have broken this U and G along x-axis and y-axis. Now if I have to find flight time, so what is flight time? It goes from O and ultimately lands at A. So when it is at A, then the displacement along y-axis becomes 0. The displacement along y-axis becomes 0 two times, one at the beginning of the projectile and another at the end of the projectile at A, means one at O and one at A. So what we will do is we will put Sy equal to 0. Now Sy we can use the kinematic equation because along the y direction U component is U sin theta and G component is G cos alpha. So Sy is nothing but U sin theta into T minus half G cos alpha T square. So if we put Sy equal to 0, we get a quadratic equation of T and the two values, it will have two values then, one is 0 and one by solving we will get as U sin theta 2U sin theta by G cos alpha. So that means these two values are one for the initial time, that means at the time of throwing, and another is the final time when it falls. That means that time gives the flight time. That means capital T flight time is 2U sin theta by G cos alpha. Again, if we have to find the range, then what is range? Range is the displacement in x direction, that is OA, in time capital T. So first we will write the formula for displacement in x direction, which is u cos theta into t minus half g sin alpha into t square, means ut minus half gt square formula. U cos theta into t minus half g sin alpha into t square. And if we put the value of t in this, t we have already got from earlier equation. So if we put t here, we will get the value of r, that is range. So that is how we find the inclined plane. We will treat like this and we will find the time period and also the range. That means what we do, we take x-axis and y-axis along the plane and perpendicular to it. We resolve u and g along these two axes. Then ux becomes u cos theta, uy becomes u sin theta, gx becomes minus g sin alpha, means it is backward, and gy becomes minus g cos alpha. So we have put this in the formula, kinematics formula, and we find t and also we find r. So this is how we deal with the problems of inclined plane projectile, because they are the projectile formula which you have learnt in projectile chapter will not be applicable. So I hope you have gone through this. Please note down this or take a screenshot of this, and then it will be very easy for you to do the inclined plane projectile. So this much today. I will come again with another concept for you. Thank you very much today.